Let me welcome you to a brand new JavaScript course in 2024. Whether you're a junior developer, computer science student, or just someone who wants to wet their feet in learning what JavaScript is, this course is for you. By the end of this course, I promise that your fundamentals of JavaScript will be rock solid, but the only caveat is in order to learn, you have to practice, and I encourage you to code along with me. I will also be leaving the timestamps in the description for your ease. You can check it out from there. This course is going to be divided into smaller chunks like part 1, part 2, part 3, but there won't be many. I'm guessing around 6 to 7 parts at maximum for you. So without further ado, let's begin this course. Before going deep in JavaScript, let's do a little theory first. By learning JavaScript and making projects, you can get a very good skill to become employable. You can become a front-end developer or a back-end developer or a full-stack developer who knows both front-end and back-end. It is increasing in demand as well, and all the big companies like Netflix, PayPal, and others create their applications around JavaScript. What can you do with JavaScript? For a long time, JavaScript was only used in browsers to make interactive web pages. Some developers used to call JavaScript a toy language, but those days are over now because it has investment backing it and a part of big community support with big companies like Facebook and Google. Today, you can create full-fledged web or mobile apps as well as real-time networking applications such as chats and video streaming services, command line tools, or games with JavaScript. The second question is, where does JavaScript code run? JavaScript was designed to run on browsers in the beginning, so every browser has a JavaScript engine that executes JavaScript code. For example, Firefox and Chrome's JavaScript engines are SpiderMonkey and V8. In 2009, a very intelligent engineer called Ryan Dahl took Chrome's open source JavaScript engine and embedded it in a different program, and he named it Node. Now through this, you can run JavaScript code outside the browser. This means that with JavaScript, you can easily create a backend for your web and mobile applications. And finally, the last question, what is the difference between JavaScript and ECMAScript? ECMAScript is just a specification. JavaScript is a programming language that follows this specification. So we have an organization, ECMA, which is responsible for defining standards. Their job is to take care of this ECMAScript specification. The first version of ECMAScript was released in 1997. Then in 2015, ECMA started working on a new specification every year. 2015 version is called ECMAScript version 6. There is a shorter name for it called ES6. This specification has defined new features for JavaScript. Now let's see JavaScript in action. As always, make sure you're doing everything what I am doing. So open Chrome, click somewhere empty and go to inspect. Now Chrome Developer Tools will open where you select the console tab. This is your JavaScript console, and here you can write any valid JavaScript code. So type console.log, then a single quote, then write hello world. Close it with another single quote, close the parentheses and add a semicolon at the end. Now press enter and you can see the hello world message on the console. We don't make real-world applications like this, but this is just a demo that JavaScript runs in the browser. Now you will set up your JavaScript environment. To write JavaScript code, you need a code editor. There are many code editors available such as Visual Studio Code or VS Code, Sublime Text, Atom, and many more. My favorite of these is Visual Studio Code, which you can download from this website. This is a very easy, lightweight, cross-platform and powerful editor. So if you don't have Visual Studio Code, then go and download it. The second thing I want you to install is Node. You can download Node from this website. Now technically, you don't need Node to execute JavaScript, but it's good that you have Node because you will use it to install third-party libraries. So pause the video and download Node with Visual Studio Code. Now I want you to create a new folder named JavaScript Basics. The name is not important. You just need a folder to write all the code in this course. Now drag and drop this folder into Visual Studio Code. Here add a new file index.html. Now you don't need HTML to take this course, but if you want to become a front-end developer, then you should have a know-how and knowledge of HTML. I have a crash course of HTML and CSS on the channel, including Flexbox, Sass, and other projects as well. Those links will be in the description. I want you to write an exclamation mark and then press the tab button. This will generate some basic HTML boilerplate code because Emmet's extension is installed in VS Code automatically. We don't care about this code yet. We will make it the host of our JavaScript code, so save the changes. Now open the extensions tab. Here in the box, search for Live Server. Live Server is a very light web server which you will use to serve your web applications. Install it, then you will have to restart Visual Studio Code. It will basically ensure that whatever changes you make, they are displayed on the browser without refreshing the browser. Now right click on index.html and select Open with Live Server. It will open Chrome or your default browser and it will point to this specific address. From here, your web application is being served. So right now you have an empty page. Now to confirm that everything is working properly, go back to Visual Studio Code and go to the body section. Code along with me now, don't you leave behind. Here we have to add an H1, so press the tab and write hello world. Now save the changes, go back to the browser. You can see that this page has been automatically refreshed and we have a hello world heading. Alright guys, you are now ready to write your first JavaScript code. You need a script element. Now there are two places where you can add a script element. You can add it here in the head section or in the body section. But the best practice is to put the script element at the end of the body section after all the elements of HTML. So here after H1, I am writing the script and pressing the tab button. This is your script element. Now why did I say that the best practice is to put the script element here? There are two reasons for this. One reason is that the browser parses this file from top to bottom. So if you put the script element in the head section, then you can save a lot of JavaScript code. So your browser will be busy parsing and executing JavaScript code, and it will not be able to render the page content, which will spoil the user experience. Your user sees the web page, and whether it is blank or white, a browser passes and executes a JavaScript code. So this is one of the reasons. The second reason is that the code you have between script elements, it has to talk to the element on this website. For example, you want to show and hide some elements. So by putting this code at the end of the body section, you can confirm that the browser has rendered all the elements. In simple words, elements are displayed on the web page. Now, there are exceptions to this rule. Sometimes you are using third-party code which is necessary in the head section, but these are exceptions as I told you earlier. According to the best practice, you should add your JavaScript code at the body section. Now write the code with me. You will write the same code as you wrote earlier, console.log hello world. But now we will talk about it in more detail. Here we have a statement that is part of a code that expresses an action. In this case, you want to log a message on the console. In JavaScript, all statements should be terminated with a semicolon, and if we see here in single quotes, this is called a string. In JavaScript, we have another notation. We can add two slashes which represents a comment. You can add a description to your code here. The JavaScript engine is going to ignore this. This is not executed. This is just to document the code. When you want to communicate well with other developers and want to tell them how the code is executing and what it is doing, then you do it through comments. I am just adding a simple comment for this demo. This is our first JavaScript code. Save the changes and go back to the browser. You have to bring the console back, so right click anywhere and go to inspect and go to the console tab. And here you can see your hello world message. Now while you can easily write JavaScript code in the middle of the script element, in a real world application you have thousands or millions of lines of code. You don't want to write all the code in a line here. You want to separate your HTML code or JavaScript code. That is called separation of concerns, because your HTML should only be used to display content and JavaScript should only be used for the behavior of that HTML, so it is not good to add them in one file. Now open the Explorer window and add a new file. It will be called index.js. Cut the current code of JavaScript and paste in index.js. JavaScript code is in a separate file. You have to reference that file here. So add an attribute here. src is short for source, so set it to index.js. This is going to tell the browser that our JavaScript code is now in index.js. Save the changes and go back to the browser. Now you can also see the hello world message, and it confirms that our code is now working. This was our introduction regarding JavaScript. What is it, why do we use it, and so on. If you like this introduction and want more introduction to new front-end technologies, concepts and tutorials, consider subscribing to the channel and like the video if you're finding it helpful. Now you will learn all about JavaScript variables of var, let, and const. Variables are one of the most basic concepts in JavaScript and any programming language. In programming, we temporarily use a variable to store data in the computer's memory, and we give that memory location a name. And with this name, we can easily read that data on the location given in the future. A variable is like a box. It is the value of what you put in the box which you have assigned to the variable, that is data. And the label you put on the box is the name of the variable. So here I am declaring a variable in index.js. In the old days before ES6, we used the var keyword to declare a variable. But there are issues with var, and the two main issues are of scope. But after we go further in the series, we will see what those issues are. Let us use let keyword to declare a variable. Now we have to give a name or identifier to this variable, which is like putting a label on the box. So I'm calling it a name. And finally, you have to terminate this declaration with a semicolon. Now let's log it on the console and see what you get. Save the changes, and here you see undefined in the console. So by default, the variables we define in JavaScript, their value is undefined. You can initialize this variable optionally, so I'm setting it in a string, which is a sequence of characters and it is denoted in double quotes. You can also use single quotes, but different developers have their own preferences, but it is more common to use double quotes to declare strings in JavaScript. Now when you save the changes, you see Saad instead of undefined on the console. You have declared a variable in this example, which is name. The next step is crucial, so watch carefully. There are a set of rules for naming the variables. First rule is to not use any reserved keywords. They are the keywords of the JavaScript language. For example, I cannot name this variable as type of, as it's a keyword for JavaScript. The second rule is that the name of the variable should be meaningful. We should use meaningful names like meaningful labels. I have seen developers using names like A, B, X1, XA and so on. These variable names don't give us any clue as to what the purpose of these variables is. Third rule is that they can't start with numbers. So we can't put a single variable like 1 name, 2 name or 3 name. But let's go back to the second rule, because why would you want to put a single variable like 1 name? It's not going to help. So always use meaningful names. Do let me know in the comments if you knew all of these rules or not. Another thing you should know about these variable names is that they are case sensitive. If I declare another variable, I call it first name, but I uppercase F. So these two variables are different. But as I told you earlier, if you follow camel notation, you won't have to write such variable names. And the last thing you should know about these variables is that if you want to declare multiple variables, there are two ways to do it. You can declare them in a line and separate them from a comma. So first name, then last name. In this case, I have not initialized these two variables, but both are undefined. I can initialize one or both as an option, so I have set it to Saad and left the last name undefined. But the modern best practice is to declare each variable on a single line. So we terminate this first declaration with a semicolon and declare the second variable on a new line. This is modern best practice. Now we will move on to the const variable. Now we declare a variable which is called inflation. So let's declare inflation at 1% and then we change it to 5%. Doing this in a real world application in which you don't want the data to change, it can introduce different bugs in those situations. So the value of a variable, as the name implies, can change, but the value of a constant variable cannot change. In this example, we changed the let keyword and replaced it with const. So when I save the changes, you're going to see the error in the console. You can see the line in code where this error occurred. Since we can't reassign the constant value to something else, it is good to use it for things we know it can't change. So here is the best practice. If you don't need to reassign, constant should be your default choice. Otherwise, if you need to reassign a variable, use let. Now, ever wondered what values can we give to a variable? Well, besides strings, there's more to it in JavaScript. We have two types, primitive types and reference types. Now, we'll dive into the primitive types. In the world of primitives, we've got strings, numbers and booleans. First up, strings. Like the variable name, holding a string literal, fancy term, right? It's just a cool way of saying it's a string. Now, let's talk numbers. Imagine a variable named age, set it to 35. By the way, I'm not really 35, but let's keep that between us. This is a number literal, a straightforward way of pressing a number in code. Next in line is booleans, either true or false. For instance, is approved set to true. It's a boolean literal, handy for logic situations. If an order is approved, you know it's time to ship. Quick note, true and false are special words. You can't use them as variable names. Now, remember undefined? It's like saying I've got a variable, but I haven't given it a value yet. You might encounter it when starting a variable without an initial value. On the flip side, there's null. Declare a variable, set it to null. We use null when we want to clear a variable's value explicitly. For example, imagine showing the user a color list. If they don't pick a color, we set the selected value variable to null. If they choose red, it changes to red. Click red again and we go back to null. Simple. So these are our primitive values: strings, numbers, booleans, undefined and null. Now in ES6, there's another primitive called symbol, but we'll get into that later in the course, so keep watching. JavaScript stands out among programming languages because it's dynamic. Well, there are two types of programming languages, static and dynamic. In static languages, once we declare a variable, its type is fixed and can't be changed later. Now, in a dynamic language like JavaScript, a variable's type can shift during runtime. Let's dive into some code to see this in action, and I highly recommend that you code along with me. In our last example, we had a variable named name set as a string. Currently, its type is a string, but watch how it can change in the future. In the console, we can run some JavaScript code using the type of operator to check a variable's type. Initially, name is a string. Now, if we reassign it to a different value, say a number, and check its type again, the type is now a number. This flexibility is what makes JavaScript dynamic. Unlike static languages, variable types are determined at runtime based on the assigned values. Let's explore more examples using the type of operator. Note that type of is a reserved keyword. You can't have a variable named type of. Check the type of age, it's a number. Even if we change age to a floating point number, its type remains a number. In JavaScript, there is no distinction between floating point numbers and integers. They're all just numbers. Is approved has a type of boolean, just as I mentioned earlier. Now what about first name? Its type is undefined, and that's amusing because the variable's value is undefined and its type is also undefined. Well, it goes back to our two types, primitive and reference types. In the primitive category, we have strings, numbers, booleans, undefined and null. So undefined is not just a value, it's also a type. Lastly, check the type of selected color. It's an object, but what is an object? Now let's explore reference types in JavaScript after covering the primitive types. In this category, we have objects, arrays, and functions. So what exactly is an object? In JavaScript, an object, much like in real life, is akin to a person with various attributes, name, age, address, and so on. These attributes are the properties of a person. In JavaScript, when dealing with multiple related variables, we can neatly organize them within an object. Consider two variables, name and age, representing aspects of a person. Instead of having these two separate variables, we can create a person object, making our code more organized. Let's see how it's done. We begin with let or const. If we don't plan to reassign the person object, we set it to an object literal. Inside the braces, we add one or more key value pairs. Keys are the properties of the object. For our person object, we want name and age as properties, so we add name with the value Saad and a comma followed by age with the value 27. Now we have a person object with two properties and we no longer need separate variables for name and age. Let's log the person on the console. The object literal syntax is evident, curly braces with key value pairs. Now working with these properties can be done in two ways. Suppose we want to change the name to John. There is the dot notation person.name where we access the property using a dot. You can also read the value using dot notation. Alternatively, there is a bracket notation, person, brackets, and then name, where we use square brackets and pass a string for the target property name. Changing the name to Matthew with bracket notation shows flexibility. Now which is better, dot notation or bracket notation? Generally, dot notation is shorter and should be the default choice, yet bracket notation has its uses, especially when the property name isn't known until runtime. For now, stick to dot notation and we'll revisit bracket notation as you gain more JavaScript experience. Now we'll talk about arrays. In your applications, there are instances when you need to handle a collection of objects like the products in a shopping cart or the user selected colors. In such scenarios, an array comes in handy for storing these lists. Let me guide you through it. I'll declare a variable with a meaningful name selected colors, emphasizing clarity over obscure abbreviations. We initialize this array as an empty one using square brackets known as an array literal. Now let's add a few items, red and blue, and log this array on the console. Our array is ready with two elements. Each element has an index determining its position, the first at index 0 and the second at index 1. To access an element, we use these indices. For example, to display the first element, we use square brackets with the index. Now we see red. I mentioned earlier that JavaScript is dynamic, meaning the type of variables and the contents of array can change at runtime. Let me demonstrate for you. We initially set the array with two elements. Now we add another green. Displaying the array shows all three elements. The length and type of objects in the array are dynamic. Unlike some languages where every item in an array must have the same type, in JavaScript we can have different types in an array. Let's make the last element a number. Now we have a mix of strings and number in the array. Technically, an array is an object in JavaScript, like the person object we explored earlier. It has properties accessible via dot notation. Checking the type of selected colors on the console shows it's an object. The properties listed are inherent to arrays in JavaScript, inherited automatically when we declare an array. Don't worry, we'll dive into this concept later when we discuss prototypes. In this session, we'll focus on one of these properties, the length property. This property returns the number of elements in an array. You will learn about all kinds of operations you can perform on arrays. For now, all I want you to take away is that an array is a data structure that we use to represent a list of items. In the category of reference types, you've explored objects and arrays. Now, let's dive into functions, a fundamental building block in JavaScript. A function is essentially a set of statements that accomplishes a task or computes a value. Let's walk through a couple of examples. I'll declare a function using the function keyword. Let's name it greet. After that, we add parentheses, part of the syntax for declaring functions, followed by curly braces. The content within these braces is the body of the function, where we define the logic. For this function, let's keep it simple and display a message on the console like console.log hello world. Note that within a function declaration, we don't need a semicolon at the end, unlike when declaring variables. Now that we have a function, we can call it by writing its name, followed by the parentheses and a semicolon to indicate it's a statement. Save the changes and you'll see the hello world on the console. It might seem basic, so let's make it more interesting. Functions can have inputs called parameters, which can alter their behavior. Suppose we want to display a personalized greeting instead of a generic message. We can introduce a parameter, let's call it name. This parameter acts like a variable meaningful only within this function. We can then use it to display a greeting such as console.log hello plus name. Now when calling the greet function, we pass a value for the name parameter, let's say John. This value is an argument for the function. Remember, a parameter is what we declare in the function and an argument is the actual value we provide when calling it. Save the changes and you'll see hello John on the console. You can reuse this function with different inputs, copy the line, change John to Mary and save. Now two different messages appear on the console. A function can have multiple parameters, simply separate them with commas. Let's add another parameter, last name. Modify the console.log statement to include the last name. When calling the greet function, pass another argument for the last name, for instance Niazi. But watch what happens if we don't provide a value for the last name, you'll get undefined. To avoid this, pass the second argument Smith. Save the changes. Functions in JavaScript offer a powerful way to encapsulate logic and enable reusable code. As you progress, you'll explore various aspects and functionalities of functions in more detail. Now, let's explore a cleaner way to write the code. The concatenation seems a bit messy, but don't worry, in a later section of the course, I'll introduce you to something else called template literals, which will tidy up this code. For now, let's move on to another example of a function. The function we've been working with so far has been performing a task, in this case, displaying something on the console. However, functions can also be used to calculate values. Consider this example of a function named square. It takes a parameter, let's call it number, and calculates the square of that number using the formula number times number. To pass this calculated value back to the calling code, we use the return keyword. Instead of calling the greet function, we pass 2 as an argument and this returns a value. We can use that value to initialize a variable like declaring result. Now in this specific example, if all we want to do is display the square on the console, we don't necessarily have to declare a separate variable. We can exclude the variable declaration and directly pass the square to console.log. When the JavaScript engine executes this code, it calls the square function, gets a value, and then passes that value to console.log. Save the changes. These basic of functions are just the beginning. In later sections, we'll dive deeper into functions. For now, remember that a function is a set of statements that either performs a task or calculates and returns a value. In a real-world application, you'll encounter hundreds or even thousands of functions working together to provide the functionality of that application. Alright guys, this was it for our part 1 for the JavaScript series. I hope you learned something new. Stay tuned for part 2 by subscribing to the channel. Like the video if you found it helpful and comment about anything and I will help you out. Also, if you want to watch playlist of mastering Flexbox, click this video.